In this video, we're going to use the Arduino microcontroller board to send data via serial communication to our Max patch. So what we're going to do is we're going to use our Arduino to control elements of our synthesizer that we've built in Max. So let's start with the patch that we built last time. So I've got my Arduino board here and it's all hooked up and programmed so that when I press this little push button, the LED comes on. Okay? Now, up until this point, we've just been using the USB cable as a way of powering the Arduino. So it's just running off 5-volt battery from my laptop and powering the Arduino. But a USB cable can carry data to and from the board and the computer. So we can use serial communications protocol to communicate between the two. Now, we're not going to dive too much into the protocol itself today. Suffice it to say that our Arduino can send and receive data, certain types of data, between the computer. So let's get started straight away. It's actually very easy to get serial communication up and running, since it's kind of already built into the Arduino. So I've got my code here. You'll see that one thing to note is that because of the RX and TX pins on the Arduino, so digital pins 0 and 1, because they can be used for serial communication, it means that if we're using serial communication, we can't use them on the board. So I'm starting at pin 2 for my push button and pin 3 for my LED. So we're ignoring pins 0 and pin 1. Okay, so you'll remember from last time that in our setup void sort of structure, this is going to run at the start when the board first powers up. So what we're going to do is we are going to begin serial communication. Okay. Then we're going to specify the baud rate, which is the bits per second, the kind of communication speed of our serial data transmission. So we're going to set it up at a kind of standard value of 9600 bits per second. And that's really all we have to do to set up serial communication in Arduino. From this point now, it's just a matter of writing out the data that we want. So for instance, what I could do at this point is just say, here where I'm checking if the button is pressed, so I'm checking the button state, all I would have to do is alongside turning the LED on, I'm going to say serial print line button state, and then I'll copy this, and then when I turn the LED off, when the button is not pressed, I'm going to do the same thing, and that's going to send, this time it's going to send a low value, or the button state will be off or 0. And that's it. That's all I really have to do to get serial working on Arduino. It's alarmingly simple. So what we're going to do, I'm going to save this. Hope everything goes right. I'm going to upload it to my board, and we're done uploading. So now I can move over to a new Max patch. But just before we do that, I'm just going to show you how that we can check this. So my button presses, my LED comes on. Now you'll see here in the top right hand corner of our Arduino IDE, we have the serial monitor. So if I open this, we will get this window. It's just spewing out a constant stream of zeros. Now, the reason for that is that with the serial print line that we're using, what that says is print the value and then create a new line. So each time it's saying 000 because the button is not being pressed. Then when I press the button, you see that switches over to a 1. So it's just constantly sending out at the baud rate, so 9600 bits per second. And I can just switch this light on and off. So that's being communicated over the serial port. Now it's Max's job to pick up and read what's going on, to intercept the data on the serial port. So before we do that, just close your serial monitor, because sometimes that can cause interference if the serial monitor is open while Max is also trying to intercept that data. Okay, so I'm in a new Max patch. Now my Arduino is still plugged in, it's still just running away. I don't need to touch that for the moment. So, first thing, Max uses an object, unsurprisingly called serial, in order to send and receive on the serial port. Now, the way we set this up is we need to define a port, which is basically like your computer will have a bunch of serial ports already set up. So for instance, Bluetooth is a type of serial port. So if you have Bluetooth on your computer, one of the ports might be for Bluetooth communication. Now this is a different one, obviously. This is running on one of the USB ports. So like in the Arduino IDE, when you set it, from the tools and drop down menu, we're gonna have to find out which port it's coming into and define that in Max. So I'm just gonna create this serial object, and then I'm gonna create a new message called print and send it a print message. Now when I hit this, you'll see that I've got my console window open here on the right hand side. This is going to tell me now the different ports that I have on my computer. So you see port A, there is my Bluetooth port. Now this other one, USB and then a bunch of numbers, that's going to be my Arduino port, okay? So I'm going to say serial B, that's the port B, and then I need to give it the baud rate. So we know from before that was 9600. So Max is communicating at the same speed as the Arduino IDE. Or the Arduino is sending it out. So with that, number doesn't understand. That's fine. Right, so with that in mind, all I then have to do is set up a Q metro, because now all I need to do is keep kind of banging the serial, let's say like this, in order to output data from it. So I can put a toggle in, Q metro, and then let's read what data we're getting out. So I create a new message and just send it to the right inlet. Now, if I press turn on this toggle, we should start to get data from my Arduino. Well, let's try and press a button. No, that's not helpful, is it? So the reason for this is, remember the print line object that I was talking about? Well, serial port communicates as different data types. It's not regular integers like if I say to you, oh, this is number 1 and this is number 2. It's creating ASCII text, okay? So when the print line creates a new line, what it's actually doing is sending an ASCII value of 13 and a new line character of 10. Okay, so it's doing it in a different form of data than Max can sort of natively understand. So we're going to have to do a little bit of translation. Okay, so this is these are the values that I'm getting out of Max at the moment, and they're not especially helpful. So what we're going to do is we're going to have a little look at some other things. So first of all, because we know that it's sending out these two values of ASCII values of 10 and 13. We know that they're going to occur at some point. So what we can do is we can kind of filter those out. And what we're going to do is we're going to group all of the values, because it's not sending 1 when the Arduino sends 1. It's actually sending some ASCII value of 1, which is not the same as 1. It's a little confusing, but don't worry, Max will take care of all the translation for us. So I'm going to pass this and this and this all into a group object, and so we should have, that looks a little bit more manageable now. That's a little bit less strange as I press this button. So what we're getting, we should be getting 0 and 1, but we're getting 48 and 49 because they are in ASCII value at the moment. So what we need to do is we need to convert some things. So we're going to have an I2A object. That's going to run here, and that's going to run into a from symbol object. Don't worry too much, these are just doing some kind of conversions. Now if we follow this again, you should see, there we go. As I press the button, light comes on and I get a number 1. Finger off, 0. Okay, so we've successfully translated this into a useful value now. So what I could do, I could get rid of these now, and I could say this is my amplifier. So I'm going to have a cycle object. So I've got a sine wave here, and that's going to go into an amplifier, and this amplifier is going to control. Let's turn this down a bit. So this should, when I press the button, there we go. So that binary value, that 0 to 1, I'm now using to open and close the amplifier of my synthesizer. Okay. Now you could do this into any number of different values. This could be a pitch, for instance. You could trigger pitches or turn this into kind of a make note to play different notes, or this could switch between menu options or different parameters and presets on your synthesizer. But let's take this a step further and let's start to think about other kinds of controllers that we could use in Macs. So for instance, here I've got a little rotary dial, a potentiometer, and we could plug this in and now we've got rotary control. Or we could use other things. We could use the LDR, the photoresistor or light sensor. We could use sensors like that to control things, and it's relatively easy to patch it into Macs. We've done all of the kind of hard translation here, and as long as you've got this set up, it's really just a matter of thinking now how we kind of unpack that data from the serial port and then what we do with it in Macs. Okay, I've just hooked up this very simple potentiometer or a rotary dial. I've hooked it up. It's really easy to do, but you might be a little put off if this is the first time you're using it because it has 3 pins. Just note that on a potentiometer, the middle pin is pretty much always the value that you're going to be reading from into the Arduino, and the outer edges are, one is going to go to 5 volts and one is going to go to ground. The other one, this middle pin that we're going to read data into, is plugged into A0, and this is on the left hand side of the Arduino on the analog in section. So how do we read an analog input into our Arduino? Because so far we've only been using the digital in and out pins. Well, it's actually a little bit easier. It's very, very similar to setting up any other digital pin that we've done so far. So first of all, we're going to set up our pin. Let's call this one sensor pin. And this is going to be set up to analog input 0. Okay, so that's all we have to do there. We just define where our pin is, and then in the void setup we don't actually have to do anything because it's always going to be an input, so we don't have to say whether it's an input or an output as we did with the digital pins. So that's taken care of. What do we have to do then? One thing I should say, sorry, I just missed this. We are going to need to set a value input. So sensor val, and same thing, we'll just set that as 0, just like we did up here. So in the loop, what we want to do is we kind of want to read this, but also we want to convert it into something more useful. So we're going to create a new, we're going to take sensor val that we defined up here already, and we're going to say that it equals what we read on the analog read, and then where did we say that was going? Sensor pin 1. Right, so that, as we read from the analog in, is going to give us a value from 1 to 1023, okay, which is a little bit big, particularly for Macs. So what we're going to do, we're just going to scale that down quickly. So we're going to take that same value that we just updated, sensor val, and we're going to update it. Okay, so we don't need to add like another variable. We can just use the same one and kind of update it. So this is going to be mapped, sorry, the value first argument, then we're going to say it goes from 0 to 1023, and we want it to go, so it's going to go from 0 to 1023 to 0 to 255. That's a little bit more sensible, right? Close that down, and now all we need to do is we can kind of do it the same way that we did before. Just down here outside the if statement, so this is all its own little bit just to check if the button's working. And this is going to print our sensor value. Easy. Unfortunately, there's a little problem, okay? Now, because we're printing our button value to the output and we're printing our potentiometer output, our serial monitor is going to get a little confused. Let's just take a look at that. So on the serial monitor now, you see that the two values I'm getting, so I'm getting 0 to 1 for the button, you can kind of see that changing, and then the other much larger number is that value from 0 to 255 as I turn the potentiometer. Now, because the two are kind of interleaved, it gets a little bit confusing and Max is going to have trouble picking those out. So what we're going to do is we're going to go back to our, I'm going to close this. We're going to go back to our code here and we're going to change some things around, okay? So what I want to use is not print line, which adds a return or adds a new line at the end, but I'm just going to use regular old print, okay? Now, what that's going to do is that's not going to create a new line after. So we're going to have to artificially add something that makes the values separable, okay? Otherwise it's all just going to get mushed up into this one giant number and we're not going to understand it. Max isn't going to understand it. It's all going to be horrible. So I'm going to add a space, okay? And we'll do that here. And then after we've got our values out, we'll add another one. And now we'll add the print line, okay? So after we've finished with all of the numbers that we need, then we'll send the print line and that will say, okay, this is the end of this loop section, okay? So all of the values that we need to send within here, as soon as we hit that return, now Max can kind of figure it out. Now, just to kind of make our point, let's add another value. This will just be an arbitrary one, okay? This will just be our sensor value times by 2, okay? This is just so that you can see how Max can deal with like 2 or 3 different controls, okay? So for instance, if you wanted to patch up a bunch of different buttons, just to show you that by adding the space each time, that's how we're going to do it, okay? So I verify my patch and I'll upload it. Now our serial monitor is a lot easier to keep up with, okay? So you see that first digit is always going to be the button. The second digit is always going to be the rotary control, the potentiometer, and then the third digit is going to be our potentiometer multiplied by 2, so doubled, okay? That is now going to be much easier for Max to unpack, and then we can route these values out and use them where we need them in our Max patch. Okay, and here's how we view this in Max. So this is the same patch as before, I've just cleaned it up a little bit. One thing to note, sometimes when you change things on the Arduino code and then re-upload them, sometimes Max will get a little stuck. If that happens, make sure your serial monitor's closed, turn off your Q Metro, and then it's a good idea to just have a little message set up with the port that you know that you want. So I want port B, so I can just reinitialize it by clicking that, turning our Q Metro back on, and there we should have our values separated out, okay? Now, the reason what I've done here is I've used the unpack message. So remember we had those kind of columns of values separated by spaces. All I have to use now is the unpack object, and I just add more values for as many kind of things that I need to unpack from that list as I need. So remember, we've got the first value is always going to be the state of that button, second is going to be the potentiometer, and then the third is going to be the potentiometer value doubled, or anything else that you want to play with. Now, that's all it is. That's all it takes to get serial communication set up between Arduino and Max. It's relatively straightforward. Now it's over to you to try things out and to start patching things up. Now obviously the first temptation when you start playing around with these things is to make very logical mappings, okay? For instance, that potentiometer, the rotary dial, it would be very sensible to kind of hook that up to something like volume, or maybe even the pitch of your synthesizer, okay? You know, just kind of like a main pitch control or something. But I want to encourage you to kind of use Max to its fullest potential. Try doing some slightly strange things, okay? So there's no reason that this button has to just turn sound on or off, okay? What I've got here is I've made a little fun little patch just to kind of demonstrate this a bit. I've hooked up, well, see if you can figure it out. So my potentiometer is now changing the rate of these kind of phasing cycles. Okay, they're moving out of sync with each other slightly because I've used this slide object up here. And then inside my chord, I'm using the button to generate random octave switches. Remember we did this right in the first video when we were building our oscillator? Well, now, as I click this button, I don't need to hold it, I can just click it. It's going to generate random octave offsets. It's going to give me some nice, interesting chord voicings. So, that's kind of the basics of getting Arduino and Macs talking to each other and doing interesting things. I will leave the rest up to you. You know, this is your chance to kind of play around with generating some interesting control mechanisms. Try other things, try LDRs. They hook up very similarly to potentiometers. You read them into the analog input. Try flex sensors, bend sensors, infrared. You can have humidity sensors and all kinds of things. They're very, very cheap to buy online and very easy to hook up. If you're not sure how to hook something up, head over to the Arduino website and the reference manual over there and get kind of get into exploring these new things. You don't necessarily have to fully understand the ins and outs of how they work. That's great if you do, but you know, Arduino makes it super easy to just take a chance and plug something weird in and see what you get and try and make some interesting kind of fun experimental instruments with it. So that's all there is. Good luck getting Arduino and Macs to talk to each other.